To the presentation on numerical solution on indicator diagram. The given data for the solution of the indicator diagram is the diagram area, indicator diagram area is 3000 mm square. Diagram length is, that's indicator diagram length is 60 mm. Spring constant is 0.8 bar per millimeter, that's 80,000 kilopascal per meter. Bore diameter is 0.1 meter. Stroke length is 0.15 meter. Engine speed is 1000 rpm. Number of cylinders is 1. Engine type is 4-stroke. The fuel flow rate is 0.022 kg per second. Calorific value is 42,000 kilojoules per kg. Torque is 200 Newton meter. Now the question is find the mean effective pressure, indicated power, brake power, frictional power, mechanical efficiency, brake thermal efficiency, and indicated thermal efficiency. To solve this problem digitally, that means using that apps like digital tools, that's computational tools. Let us first let us add that input to this problem is if you see the input to the problem, that's number of stroke is for this 4-stroke engine, a single cylinder engine, number of cylinders is 1. The speed is supplied as 1000 rpm. Bore diameter is 0.1 meter. And stroke length is 0.15 meter. Length of the indicator diagram is 0.06 meter. And area of the indicator diagram in meter square 0.003. And torque is in 200 Newton meter. Spring constant is 80,000 kilopascal per meter. Mass of the fuel is 0.002 kg per second. Calorific value is given as 42,000 kilojoules per kg. Now, after this entry, now you can see the results. The mean effective pressure is 4,000 kilopascal. Area of the cylinder, that's 5/4 d square, is 0.01 meter square. Indicated power is calculated from the PLAN x by 60. The first is the mean effective pressure is area of the indicator diagram by length of the diagram into spring constant. So that gives the, if it is a spring constant is taken in kilopascal per meter. Now in mean effective pressure you can measure in calculate in terms of the kilopascal, that's 4,000. Similarly, indicated power is a product of mean effective pressure, length of the stroke, and area of the cylinder, number of effective stroke. The number of effective strokes are, if it is a 2-stroke engine, it is equal to the speed of the engine, that's n. With the number of, that means the engine is a 4-stroke engine, number of effective strokes will half of the number of, let us say n by 2 we have to take as number of effective stroke. So where x is the number of cylinders. Now it's x is equal to 1. So indicated power is coming as 39.27 kilowatts. Whereas the brake power is the product of torque into angular velocity T into omega, that is 2 pi nt by 60, where n is the rpm and T is the torque. Since it is a kilowatts divided by 60,000 we did here. So the after substitution of this speed 1000 rpm and torque is 200 Newton meter, the brake power is 20.94 kilowatts. The friction power is the difference between the indicated power and the brake power. So that's coming as 18.33 kilowatts. And mechanical efficiency is the ratio of brake power and indicated power. That's equal to 53.33%. And the indicated thermal efficiency, IP by MF into CV, that is 46.75. Similarly, brake thermal efficiency is BP by MF into CV is coming as 24.93%. Here we have the flexibility to change that data. Let us say instead of 1000 RPM, if you are giving 1200 RPM, how the results are changing. That you can see here the change in the result. Similarly, indicator diagram area also, if it is a 0.004, then slightly how the results are changing. All these dimensions also we can change, length of the indicator diagram, can be changed, torque can be altered. So this facility will give the that means flexibility in the numerical solutions, and also we can simulate how what the effect of these conditions. So these summarizes the solutions of this finding the mean effective pressure, indicated power, and brake power. Brake power is calculated, and frictional power is calculated. Difference between IP and BP. And similarly, mechanical efficiency, indicated thermal efficiency, and brake thermal efficiency has been calculated. This is a display of digital tool. That's apps. Apps has been developed and solved to get the solutions.